So let's get started with today's session. So today we are going to talk about decision trees algorithm, which is basically quite powerful algorithm, and we are going to discuss that. We'll understand the mathematics behind the same, and we'll quickly go through the Python code as well, how to execute the same in Python using the scikit-learn package. So let's get started. So what is a decision tree? Decision tree is basically nothing but something like a tree-like structure, which is helping me to get the output in the form of a if-else type of condition, right? So that is the idea. Here you can see that a decision tree is like a flow chart that helps you make decisions by asking series of questions. Imagine you are trying to decide what to wear. So here you can see that it's giving me the output. So is it raining? If it is yes, then you have to wear the raincoat. If it is no, then in that case, it will ask another question that is it cold or not? If it is cold, then you have to wear a sweater. And if it is not cold, then you can have a t-shirt as well. You can wear the t-shirt as well. So in simple terms, a decision tree helps break down complex choices into series of smaller, easier decisions, guiding you to step by step to the best choice based on the information you have. So that is the idea. So let's see with one example. Now decision tree we can use in for regression as well as classification. So I'm assuming that you are aware of the same. So regression is basically nothing but where I want to predict the continuous variables. For example, I want to predict the house price, car price, and so on. So we can very well apply in the regression, plus we can apply in the classification as well. So basically whether something will happen or not, whether my customer will purchase the product or not, whether my patient will get disease or not, right? So I can apply in the classification as well. It is not language specific, it is a mathematical algorithm. And we can apply in Python, we can apply in any other programming languages as well by writing your own code also. So decision tree for classification is a model used to predict the category or label of a given input. It starts with a question, it increases the branches, it go ahead and ask for yes or no. So we'll understand that more in detail. This is just a text. You can go through that later on. I will share the PPT. Same way as I mentioned, it works with the regression as well. So the idea is that if I want to predict any continuous variable, in that case, that is considered as a regression. For example, I want to predict the house price and so on. Now, under the hood, in the decision tree, there are three algorithm runs. One is known as cart algorithm, and that is what we are going to discuss in this particular session. Now, the cart algorithm is also known as classification, regression, and regression trees, basically. So I can apply the classification, I can apply the regression using this particular algorithm. Here are the steps of cart. So basically, we'll start with the entire data set and then we'll split the data based on certain conditions in classification. We are focusing more on the classification today. So in classification, we have a concept of Gini and entropy. That is the measure of impurity. So we can go ahead and we can use that concept and we can very well do the predictions, right? So we'll understand Gini concept today. We are focusing on, because it's a 1 hour session, so I'm not going deeper into all the concepts. We are going to work on the Gini for classification in this particular session. So let's go ahead and we'll take one example. Before that, we'll try to understand what is Gini impurity, right? Gini impurity is basically nothing but it is a measure of impurity. For example, let's say I'm having a bucket which consists of 4 apples. At the same time, I am having one more bucket which consists of 4 chits having apples. Now, what is the probability of me picking up a fruit and picking up a chit? Both will give me the apple. The probability is 100% because in here we have all the apples. In here as well, we have all the apples, right? So the probability of picking up the apple is 100%. That means this is a pure data. because we have only one type of information present. But in the real-time scenario, it is not the case. Suppose, let's say, you will get a chance to submit the feedback after this particular session. So there will not be a chance that all will like the session or all will not like the session. There can be a chance that some will like, some will not like. So same goes here also. For example, I am having one more bucket, which consists of 2 apples and 2 bananas. And here we have 4 chits, wherein 2 we have written apple and for 2 we have written banana. Now, what is the chance that if I pick a fruit and I'll get banana, let's say. So now it is 50%. 50% chances are there that I will pick a banana, and at the same time, the chit will also be banana as well. So this is the impure data. 50% is like very impure data, right? Because in that, getting the output with a probability of higher will be like almost 50-50. So that's the reason it's more of an impurity which we have. So Gini impurity is a measure of how often randomly chosen element from the set would be incorrectly classified if it was randomly labeled according to the distribution of labels in the subset. The formula for the Gini impurity is 1 minus summation of pi square, where I is from 1 to C, where C is nothing but number of classes. For example, my patient will get disease or not, yes or no. So we have 2 classes. So this is nothing but the summation of the probability of yes and no. So it will be something like this: 1 minus probability of yes square plus probability of no square, right? Where I is nothing but 1 to C for first class and second class. This, let's say, first class, and this, let's say, second class. So this is the formula, or I can say this is the formula for the Gini impurity, which we are going to use for our entire calculation today. Now let's try to understand with one example, which will give us a better understanding about how it works. Here you can see that how the Gini impurity moves when all are zeros, all are ones. Let's try to understand this also quickly. What is the formula for Gini impurity? The formula says that 1 minus summation of I is equal to 1 to C pi square, or I can very well write it as, for 2 class classification, I can write it as 1 minus probability of yes square plus probability of no square. That is the formula which we have. Now let's consider 3 scenarios. Scenario number 1. Let's say I see around 150 plus learners in the class. So out of 150, all are saying that they are liking the class, and 0 are saying that they are not liking the class. Scenario number 1. Scenario number 2 is 0 are saying that they are not liking the class, and 150 are saying, sorry, 0 are not liking the class and 150 are saying that they are not liking the class. Basically, 0 means there is a negative review, right? And the third scenario is 50-50. 50% people, that is 75 people, are saying that they are liking the class, and 75% people are saying that they are not. 75 people, 50% people are saying that they are not liking the class. So now let's put the probability. So 1 minus probability of yes. All are yeses, right? So probability of yes will be 1 plus probability of no. When I solve this, you can see that the output is coming as 1. Let's go here. 1 minus probability of yes plus probability of no. That is again coming out to be 0. And the third one, 1 minus, what is the probability of yes? 50%, right? So it's gonna be 0.5 square plus, again, probability of no is also 50%. So 0.5 square, that is coming out to be 0.5. Because 0.25 plus 0.25, that is 0.5. 1 minus 0.5 is 0.5. So that is what the value is. And that is what you can see here also. When all are saying that they are not liking the class, the Gini is 0. When all are saying that they are liking the class, then also Gini is 0. But when there is a 50% case, in that case, the Gini value is highest, that is 0.5. And that is what we have seen here as well. So basically, when there is a more impurity, higher the value of Gini, right? When the data is more impure, that means higher the value of Gini we have. So with that note, let's start with one example. We'll try to understand how this calculation works in the real-time data set. So here is the data set where I want to know whether the game will happen or not. So this is my y variable, which I want to predict. In future, if a new data point will come in, I have to predict. Basically, that is what the machine learning is, right? I am helping machine to learn from the data set which we have. And in future, if a new data comes in, I want to predict whether the game will happen or not in this particular example. And we have, these are the x's. That is nothing but my independent variable. And this is my dependent variable. So this is what I wanted to predict, right? So let's use this data set and apply the cart algorithm. Can we have two variables with or and clause? What two variable? I'm not clear with what you're asking. The goal is to predict whether the game will happen or not based on these features, right? So that is what the requirement is. So let's try to understand. The very first step which I have to perform is I will calculate the overall Gini. That means I will not consider these columns. I will only consider this column, play. And you can see that we have how many records? We have total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 records are there. And out of 14 records, there are 9 records which are coming as yeses. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 records are yes. So what is the probability of yes? 9 by 14. And what is the probability of no? 5 by 14. So basically here I am using the formula for the Gini. 1 minus probability of yes square plus probability of no square. I am getting this value, that is 0.459. It's more towards 0.5 because it's almost 50-50, right? It's almost 50-50 ratio which we have. So I'll keep this aside for now. I calculated this number. I will keep it aside for now. Now let's proceed further. What is the next step? This is what machine will do. And if you want to write your own logic, this is what you have to do as well from your side, right? So now next what I have to do is I will focus on the Sunny records because now I am going to focus on Outlook, right? Now I want to focus on Outlook. So now what happens? In Outlook, we have 5 Sunnies. Right? So out of 5 Sunnies, how many yeses are there? So we have 1 yes and 2 yes. So we have 2 yeses and 3 no's. So what is the Gini for Sunny? Gini for Sunny is 0.48, right? So applying the same Gini formula. So we got the Gini for Sunny. Now I will focus on the next, that is the overcast. I'm focusing on the Outlook only. I calculated for Sunny. Now I am going to focus on overcast. In overcast, you can see that all are yeses. And when all are yeses, what is the Gini? The value of Gini will be 0. That is what we discussed. Same way I will calculate for rainy as well. So this is the rainy. In rainy, we have 1 yes, 2 yes, 3 yes, 1 no, and 2 no. So 3 yeses and 2 no's. Again, I will calculate using the Gini formula. I got 0.48. So I got the Gini for Sunny separately. I got the Gini for overcast separately. And I got the Gini for rainy as well. Now same cycle will happen with other features as well. But before that, one more thing I have to do is nothing but I want to calculate the weighted average of the Gini. Because there are 14 records. But out of that, only 5 records are sunny, 4 records are overcast, and 5 records are rainy. So I will give whatever Gini I got from individual features. I will not consider the entire Gini, rather I will consider the weighted average, right? So basically 5 by 14 into the Gini of sunny plus 4 by 14 into Gini of your this feature, that is overcast, and 5 by 14 of Gini of your rainy. And this is the number which I got, which is known as weighted average of Gini for Outlook feature. So this I will keep it aside. So now this I have. Now the same thing will happen for temperature. The same thing will happen for humidity. And at the same time, the same thing will happen for windy as well. So let's quickly go through that as also. So now I am going to the temperature. In temperature, we have hot. In hot, we are having 4 records. And out of those 4 records, 2 are no's and 2 are yeses. So 2 are no's and 2 are yeses. I will calculate the Gini for hot. Same way I will calculate the Gini for mild. Same way I will calculate the Gini for cool as well. So here you can see in the next slide, I am calculating the Gini for mild. There are 6 records for mild. And out of that, 1 is yes, 1 is no, 2 yes, 3 yes, 4 yes, and 2 no's. So we have 4 yeses and 2 no's. And we are calculating the Gini for mild. Same goes for Gini for cool as well. 1 record, 2 record, 3 record, and 4 record. 1 yes, 1 no, 2 yes, 3 yes. So 3 yeses and 1 no. I will have the calculation again coming in. And this is the Gini for your the third value of this particular column, that is temperature column, cool value. Same goes for your humidity also. Before that, again, we have to calculate the weighted average 4 by 14 because there are 4 records for your hot. So 4 by 14 of the Gini of hot, 4 by 14 of your Gini of mild, and 4 by 14 of your, this should be 6, right? 6 by 14. So you can see that 4 by 14, 6 by 14, and 4 by 14. So this is again the value coming in, which is for your temperature, right? I think this number I need to check. This number should be different. This number should be around 0.4, right? We'll check it out. 4 by 14 into 0.5. So 0.143. 6 by 14 into 0.444. So that is your plus 0.19. And lastly, 4 by 14 into 0.375. So 0.11. So let's add 0.11 plus 0.19 plus 0.143. So 0.443, right? So this number we have to change. 0.443. Okay. 4 by 14 is basically nothing but how many records are there for hot? Ajit. So 1, 2, 3, and 4. Out of how many records? 14 records. I am not taking the entire Gini of the hot. I am taking the weighted average. 4 by 14 of the Gini of hot. And same goes for other records as well. Now the same thing will happen for your third feature, humidity. In humidity, we have what? We have 1, 2, 3, 4, 5, 6, 7 highs are there. Out of 7 high, we have 1, 2, no, 2 yes, 3 no, 3 yes, and 4 no, and 3 yeses. I'll calculate the Gini for high. Same way I will calculate the Gini for normal also. It's a weighted average for every value of that column, right? Same goes for normal as well. So we have 6 normals, 1, 2, 3, 4, 5, 6, 7 normals. Out of that, 6 as yeses, right? We have to focus on this column and this column. So 1, 2, 3, 4, 5, 6, 7, and you can see 1 yes, 2 yes, 3 yes, 4 yes, 5 yes, 6 yes. So 6 yeses and 1 no. We'll calculate the Gini for that also. Now I will calculate the weighted average. Because there are 7 records for 7 records for high upon total number of records into the Gini of your that feature, which we calculated in the previous slide. Same here also, 7 by 14, because 7 records are there for humidity. That is normal, and 0.245 is the Gini for that. So this is the number which I am getting, that is 0.367. So this is for the humidity weighted average of Gini. Now same will happen for the last feature as well, that is your wind. Now if you see in the wind we have weak records, 1, 2, 3, 4, 5, 6, 7, 8 weak records are there. Out of that, 1 no, 1 yes, 2 yes, 3 yes, 2 no, 4 yes, 5 yes, and 6 yes. So 6 yes and 2 no's. So here is the Gini for weak. Probability of yes plus probability of no, square of that. So that is the Gini which I got for the weak column, weak value in that column. Now I'll focus on strong. So 1, 2, 3, 4, 5, 6. 6 records are for strong. 1 no, 2 no, 1 yes, 2 yes, 3 yes, and 3 no's. So 3 yeses and 3 no's. So here you can see that for strong we have 6 records, 3 yeses and 3 no's. So my Gini will be 0.5, that is maximum because it's 50%. Then I will calculate the weighted average again for humidity. So 8 by 14 into the Gini for your that feature, that is nothing but weak, and 6 by 14 of the Gini of the another feature, that is strong. So you will get 0.428. Once we calculate all these, you can see that these are the numbers which we calculated, right? We calculated what? We calculated the outlook Gini average, weighted average, right? This is Gini for windy and not humidity. What? Yeah, that's fine. Typo you can ignore, Armit. So here you can see that understanding is important, right? Don't see the typos and all. So we have outlook Gini, that is nothing but your what? Gini for outlook, that is weighted Gini which we calculated. Same way for temperature also we calculated this. Same way for humidity also we calculated, and same way for windy also we calculated. Now out of this, which has a lowest Gini? So the lowest Gini is for outlook, right? And if you remember, we discussed that lowest Gini is good, right? If you go back to the definition of Gini, what was that? If I am having 4 apples and 4 chits, the Gini will be lowest, that is 0. That is what we calculate here. If all are yeses or if all are no's, the Gini will be lowest. When it is 50-50, the Gini will be highest. So when I want to choose the feature, because see, I want to do what? I want to create one flow chart. I want to create one if-else condition. So I got to know that Outlook has the lowest Gini. So that will be my starting point, because that is the lesser impure feature, right? Gini is less means what? Lesser impure feature. Ruchita, for Outlook, it is 343 only. It's not 443. For temperature, it was 443. For Outlook, it is still 343 only. You can calculate from your side also. So now out of this, Outlook has the lowest Gini. So that will be the deciding factor for me. That has the lowest Gini, so I'll go with that. So now what is the next step? Outlook is the key factor. And in Outlook, we are having three values. One is sunny. Second is overcast. And third is your rainy. Now, what does that mean? It means that if someone will come to me and says that whether the game will happen or not, the very first question which I will ask, what is the outlook? Whether it is sunny or overcast or rainy. Okay. Now what next? Because if someone says that, okay, today is sunny, or if someone says that today is overcast, or if someone says that today is rainy, then what next? So now the next step is what we will do. So as we got to know that Outlook is the best feature, I am going to only focus on Outlook's individual features. Okay. Because see, Outlook, you decided that, okay, today is sunny. Now after sunny, what? Shall I say that game will happen? Shall I say that game will not happen? Can you explain once again why minimum Gini is taken? What is Gini? Gini is nothing but measure of impurity. If I am having, just think logically, I have 4 apples and I am having 4 chits where apple is written. If I will pick a chit and if I pick an apple, what is the probability that it will be picked as apple? Renuka. 100%. Because all apple, all apple. So what will be the Gini in that case? The Gini formula will be 1 minus probability of apples plus probability of other fruit. There is no other fruit, right? So that is 0. Second scenario. We have 2 apples, 2 bananas, and in the chit, we have apple, apple, banana, banana. Now, what is the probability of me getting apple? 50%. So now what is the Gini? Gini will be 0.5. Now you tell me, suppose in the class, we have 100 students and all are saying that we are liking the class. Will that be the best case scenario to predict for the new record? If a new student comes in the class, the probability of him to be liking the class will be higher because all are liking the class. Same way, if in my class 50% people are not liking, 50% people are liking. If a new guy will come in, what is the chances for him to get like he likes the class? 50%. So which scenario is better? This scenario. Because here I can easily understand. So same way, can I say that when Gini is lesser, that feature is more relevant for me? So that's why I'm going with the Outlook, because Outlook has the lowest Gini. Okay. I hope this answers to all of you. So now once we got that, what next? Now I will only focus on Gini. I will only focus on Outlook and do the calculations. So now I will focus on sunny for now. In Outlook, we have 3 values: sunny, your overcast, and your rainy. So now we'll focus on sunny. In sunny, again, we will see. With sunny, I will focus on temperature. Because see, once someone comes in and says that, okay, today's outlook is sunny, then what next? I will look for temperature. Now in temperature, 2 are hots, right? There are 2 records for hots. and both are no's, right? Both are no's. So in that case, my Gini will be 0. Same way, I will do for mild as well. There are two milds. No, I think there is only, yeah, there are two milds. One no, one yes. So my Gini is 0.5. And same way cool. Only one cool with one yes, Gini is 0. So basically what I did, I went ahead and took these two columns. And I'm trying to calculate the Gini. Gini for hot, Gini for mild, and Gini for cool separately. For sunny records. Because after sunny, I want to know what next. So that's why I'm calculating this. Once that is done, I will again calculate the weighted Gini. So 2 by 5 into 0, 2 by 5 into 0.5, and 1 by 5 into 0. That is 0.2. Same I will do for next feature, humidity. Right? Sunny humidity. Now I am considering these two. So in that we have 3 highs and all are no's, 2 normals and all are yeses. What will be my weighted Gini? My weighted Gini will be 0 because it's pure node, right? Sunny, when all are highs, it is no. And when all are normals, it is yes. So basically, here you can see that Gini humidity given sunny. Gini of humidity given sunny is 3 by 5 into 0 plus 2 by 5 into 0. Because my Gini for high is 0 and my Gini for normal is also 0. Because in high we have all no's, Gini will be 0. Normal, all yeses, Gini will be 0. So my Gini is coming out to be 0. What was the Gini coming out to be? Like what was Gini I got for temperature? Weighted Gini 0.2. For this humidity, I got 0.0. Right? Now we'll do for third one also. That is wind. So in wind, we have 3 weeks. Out of that, 1 no, 2 no, and 1 yes. So I'll get this Gini. Same way, I have 2 strongs, 1 no, 1 yes. That means my Gini will be 0.5. So I will calculate the weighted Gini. Now I will calculate the weighted Gini. And my weighted Gini is coming out to be Gini. It's not humidity, windy again. So Gini windy given sunny is 0.467. So basically what happened? I calculated outlook with temperature and I got the Gini of 0.2. I calculated outlook with humidity. I got the Gini as 0. And I calculated outlook with windy and I got the Gini as 0.467. So which is having the lowest Gini? The lowest Gini is humidity, right? Humidity with Gini as 0. So what does that mean? If it is sunny, my next question will be, what is the humidity? Humidity will be, there are two options, high and normal. If the humidity is high, if the humidity is normal, what is happening? When humidity is high, game is not happening. And when the humidity is normal, game is happening. So basically here, humidity is high, game is not happening. Humidity is normal, game is happening. So my tree is growing now. My decision tree is growing now. And this is the final. Here I have all the no's. Here I have all the yeses. There is no mix match. So this is a pure node. This is a pure node. So if someone comes to me and says that today is sunny, what will happen? I will ask, what is the humidity? He will say today humidity is high. I will say game will not happen. If he say humidity is normal, I will say game is happen. Game is going to happen, right? So that is the sunny part I have taken care. Now same I have to do for the next feature, that is overcast. In the outlook, the next feature is overcast. And overcast is simple. Why? Because in overcast, all are yeses. So if someone comes to me and says that overcast, All are yeses, right? So I don't have to look other features. So directly in the overcast, I can say that game will happen. Because I don't have to calculate the Gini's with other features. Because directly in the overcast, I'm getting all the yeses only. So I'll go with that. So that is my final answer for overcast. Let's do for rainy also. So now I am focusing on rainy records. In rainy records, I'll first focus on the temperature. Rainy, mild and cool. There are two options only. There are three milds, one yes, two yes, one no. So 2 by 3, 1 by 3, 0.444. Same way rainy, cool. One yes, one no. 0.5, 0.5, right? So here is the weighted Gini for temperature, that is 0.467. Same way outlook and humidity. One high, two high, one yes, one no, 50% Gini. Three normals, two yes and one no. So you will have Gini of 0.444 for normal. My weighted Gini will be 0.467. So my weighted Gini for temperature is also 0.467 and my weighted Gini for humidity is also 0.467. Now we'll go to the third feature. Now my third feature is what? Rainy, weak wind. For weak wind, all are yeses. And for strong wind, all are no's. That means my Gini will be 0 with the weak column, right? With the wind column, sorry. So now what is the game? The game is that outlook and rainy, outlook equal to rainy and windy is important feature for me. So here I will expand and I will ask, what is the wind? Is it weak or is it strong? If it is weak, game is happening. If it is strong, game is not happening. If it is weak, game is happening. If it is strong, game is not happening. Right? So this is how my entire tree is generating like this. This is my final tree. Now you come up with any possible scenario. I will answer. Suppose you say that, okay, today is rainy. I will ask, okay, what is the wind? You will say wind is strong. I will say game will not happen. Suppose you say that today is sunny. I will ask, what is the humidity? You will say it's normal. I will say game will happen. Suppose you will say outlook is overcast. I will say game will happen. So come up with any possible scenario. You can see that I can give the answer. And this entire thing is possible because of all the calculations which we did in the previous slides. And in Python, we have to do this code as well. The idea is that in Python, this entire coding is implemented by default. There is a package called scikit-learn. That is what we normally use. Under the hood, they are using the cart algorithm, the algorithm which we have discussed with certain modification from their side. But that is what the idea is. And that is what we have to run. In Python, this entire calculation happens in a single line of a code. I don't have to write bigger lines, just few lines and I'm done, right? So we'll quickly see that in some time. Here are certain advantages and disadvantages of decision tree. Advantages are again easy to understand and interpret because see, if you get this type of chart, you can easily understand, right? What if selected data is available? Let us say Outlook is not available all the time. Then I will not be able to predict. Then I may have to go with some other algorithm, right? Normally, we are doing a missing value treatment. This is basically nothing but when the data is available and we are doing the prediction. If the data is not available, then I cannot predict anything, right? Whether the customer will purchase the product or not based on his gender. If I am not aware of his gender, I will not be able to answer whether he will purchase or not. Same is happening here also. So you should have the information to do the prediction. Suppose you will get a loan or not based on your credit score. And now you are saying that I will not give you the credit score. Then how will I answer whether you will get a loan or not? Right? So that is how it works. Will this be accurate in search result? This will be mostly, it's a classification problem. So this is good for not search, but I can say it's more of a classifying something. right? Suppose there is a document. I want to know whether this document is risky or not, whether the email is spam or not. So that type of problem statement can be solved using this. So these are the advantages and disadvantages. First of all, advantages. Easy to understand and interpret, because as I mentioned, right, if you have this type of flow chart, I can answer easily. If someone will say that game will happen, I can give the reason also. Suppose someone asks me that why the game is happening. So I will say that humidity is normal and it's sunny. That's why game is happening. So I can interpret, I can backtrack. If something goes wrong, I can backtrack and I can give my reasoning. For example, patient will get disease or not. I'm saying he will get the disease. So he may ask, why? Then I can say because your smoking habits or something like that, based on the tree. So interpretability is very important, very easy here in the decision tree. No need of feature scaling. Basically, this is one of the techniques where we are converting the numbers into the same scale. So that is not needed. It can handle both numerical and categorical data. It captures non-linear relationships as well. So there should not be any linearity required. If it is non-linear, then also it will work fine. It handles multiple output problems also. As of now, we discussed two problems, whether the game will happen or not. Suppose, let's say we have three outcomes. Game will happen, yes, no, or might be. So I can do for prediction for might be also. So I can take care of multi-class classification as well. It's not that I can only say yes or no. I can come up with third category also if the data is if the information is available with me, right? Feature importance, decision tree again help me understand which is important feature. For example, game will happen or not. Outlook is important feature for me, right? So I can understand that, okay, outlook is very important for me to predict whether the game will happen or not. Required less data preparation. Whatever data I'm having, just few fine tuning of data will lead to the quick predictions and implementation of the model. Disadvantages, it tends to overfit. Overfit is nothing but basically your model will not perform good. It is basically biased type of model, right? So it will not perform good. So when you are applying the decision tree, you have to take care of that overfitting part by doing the pruning. Now pruning is what? Pruning is basically nothing but suppose you are generating a tree. You will cut the tree in between. Pruning is nothing but cutting the tree. When you are increasing the depth of the tree, depth is what? Depth is nothing but suppose you are creating the tree, right? So basically you are increasing the depth. So when you are increasing the depth of the tree, then what happens? There can be a chance of overfitting. And for that, I have to cut the tree, right? So that again, you are going to learn more in detail if you are going through the machine learning program and all. So that is the problem. Overfitting is a problem, sensitive to small variance in the data, because again, it's because of the overfitting only. Bias towards dominant classes. For example, let's say I want to know whether the email is, whether the transaction is spam or not, or whether the transaction is fraudulent or not. In the bank, normally the transactions are less fraudulent, right? If I am having 100 records, mostly 2-3 records will be fraudulent transaction. So non-fraudulent transactions are more. So it is biased towards the dominant class. My dominant class is non-fraudulent transaction. So when you are applying the decision tree, there can be a chance that when you are giving the data, which is like a non-fraudulent transaction, model may say that it is a, sorry, you are giving the fraudulent transaction, your model may say that it is a non-fraudulent transaction. There can be a chance because it is dominant towards the positive, dominant class, right? Bias towards the dominant class. Greedy nature, not well suited for very large data set, poor performance on unseen data set, complex trees are hard to interpret. As of now, this tree is very simple. But when the tree will be a complex tree, in that case, it is very difficult for me to understand. Right? So that is one problem we have. These are the practical applications of your decision tree you can apply in the customer relationship management, whether the customer will leave me or not, right? Churn rate. We can apply in the insurance, fraud detection, and same way we can apply in other different industries as well. Here is one of the simple code which I have created for your reference. So here is the data set which I am having, which is showing me whether loan status, whether the customer will get loan or not. Can we apply in the fault detection? We can do that, yes, whether the fault is there or not, or whether the fault will be coming or not, right? So we can do that. But you should have data for machine to get trained, right? That is important. So my interest in this, I want to predict the loan status, right? I want to understand whether the customer will get loan or not based on various features, based on the gender, based on the marital status, based on the dependents, and various different features are there. I'm creating certain charts, basically helping me understand that how the education is impacting. I created this important chart, which is very important for us to understand. Here you can see that credit history. There are two values for credit history. One is 0 and one is 1. 1 means the credit history is good. 0 means credit history is bad. And you can clearly see that when the credit history is bad, almost negligible people are getting loan. The orange is nothing but 1. 1 nothing but loan status. That means they are going to get the loan. And 0 means they are not going to get the loan. So here you can see that because of the orange color, which is very small, that means very less people got the loan when the credit history is 0. So I can clearly say that credit history is one of the important features for me to decide whether the customer will get loan or not. Right? That means when we are applying the decision tree, there can be a chance that the first node which I will have will be credit history. What is your credit history? 0 or 1? After that, maybe the tree will grow further. Depends how machine thinks, right? Based on the calculations. We already discussed that. So credit history can be one of the important features for me to decide. That is the first feature which we can have. After that, I applied the model. I did some data cleaning, right? So there are some missing values. I just took two features, that is gender and the credit history. You can use other features as well. And here you can see that I did some cleaning and applying. Gender is, again, you can see gender is nothing but male and female, right? Male and female. It's all mathematical calculations. So I cannot take the strings. I cannot take male, female for calculations. So what I'm doing is I'm applying it to one hot encoding where I'm converting the gender to zeros and ones. Whenever it is 0, it's female. Whenever it is 1, it is male, like that. Same way for education also, same way for credit history. Credit history is already 0, 1, so I don't have to do any change. Then here I'm applying the decision tree. So here you can see whatever calculation which we did, right? Whatever calculation which we did in the entire PPT, this is what the 3 line of code did, right? This is the 3 lines of code which is doing the same calculation. Whatever we did here at the above, all these are nothing but data cleaning. I was cleaning the data. The actual decision tree algorithm is this 3 lines of code. I called the decision tree classifier. I applied the decision tree classifier using the Gini, and then I'm fitting the data X and Y, and my algorithm is ready. So implementation in Python is not a challenge. It is very easy. Quick 3-4 lines of code and you are done. But understanding the maths is important. That's why I focused more on the mathematical part, basically how the calculation happens. And if you are coming from any other programming language, and if you want to go ahead and you want to create your own code in that programming language, if you know the math, then you can create your own logic easily. You can write your own code easily, right? So understanding, when you are getting into machine learning, understanding the mathematics behind it is important, because once you are aware of the maths, you can write your own code as well without any problem. Okay, so that is what I wanted to cover. It was a quick session, 1 hour. So in 1 hour, I have to cover all these things. But any doubts you can have, you can let me know. How to apply this into customer products? That depends on what type of data you are dealing with. Whether the customer will purchase the product or not, I want to predict. I can create the algorithm. Whether my customer will ask for refund or not. I can do that. So that type of thing we can go with. What are the other criteria available apart from Gini? The other criteria which we have is entropy. The formula for entropy is minus probability of yes log to the base 2 probability of yes minus probability of no log to the base 2 probability of no. Right? But we are not using entropy quite extensively because we have log in this. And when log coming into the computer calculations, it will slow down the performance. That's why in the scikit-learn also, if you go to the scikit-learn website, let me show you. If you go to the scikit-learn website as well, you can see that the default criteria which they are taking is Gini. We have Gini, we have entropy, we have log loss. Log loss is on the same lines of entropy only. So Gini is what popularly used, and by default Gini only we are using. Okay, so entropy formula is this: minus probability of yes log to the base 2 probability of yes minus probability of no log to the base 2 probability of no. I'll share this document and all with the support team. They can share it with you guys. Any other query, any other doubts? Let me know. No, that is the end of the session. No, nothing to discuss now. Just a 1 hour session. Wanted to quickly talk about this. And yeah, we'll see you in another session if there are no doubts. I'll share the PPT to the support team. They will share it with you guys. What will be the approach if the data is not conclusive? If the data is not conclusive, in that case, see again, whatever data I have shown you is for the training point of view, right? So you will see that all are yeses or all are no's. But there can be a chance that in my data set, I will not have all yeses at the end, the root node. So we'll go with the majority. Right? We'll go with the majority. For example, I have created a tree. Now here, 400 are yeses and 100 are no's. And here, 200 are yeses and 500 are no's. So I'll go with yes, majority, no majority. We'll go with the majority class. Because in real-time scenario, there can be a chance that at the last node, I will have mix of data, yes and no. And I cannot increase the size of the tree. Because if I increase the size of the tree, it may lead to overfit. So that's the reason we'll prune the tree, we'll cut the tree, and we'll finalize with certain depth. And with that, whatever the value is in the last node, we'll go with the majority. Right? Thanks, Tushar. Is there any chance of overfitting if we increase depth of? Yes, when you are increasing the depth, overfitting is happening. That is why you have to find the best depth. And to find the best depth, there are different techniques to do that, like k-fold cross-validation technique, grid search technique, all those options are available. So finding the best depth is your task. Using k-fold technique, you have to do that. When you are increasing the depth, it will lead to overfitting. When you are decreasing the depth, it will lead to underfitting. So we have to go with the optimal depth. And that is what our task to find out. What is the optimal depth? It's purely depend on data to data. I cannot say that 5 is the best depth. It's purely based on the data. Yeah, in that case, it will be probable outcome. What is the probability? Which has the highest probability? We'll go with that. Right? Because in real-time scenario, you will not get the pure nodes. This is only for the training purpose. I have shown you the pure nodes. that in the last node we are having all the yeses or all the no's. But in real time scenario, that is very difficult to get. So in that case, we'll go with the higher probability. All right, so I think I'm done. Any doubts, let me know. Last 3 minutes. If not, thanks for your time. Task is to Your task is to find whether the bounce will happen or not, right? So you have to use all the data. It's not well suited for searching. It's only for the classification, classifying the things. You are searching something and you want to classify whether this document is relevant or not. In that case, you can go for it. All right, so I think I'm done. How to code for Python regression, we'll discuss that in maybe some separate session. This is mostly focused on the classification. But if you want to know, you can go and search in scikit-learn decision tree regressor. That will give you the idea how to do the coding in coding regression in decision tree. Okay. Is it required to convert categorical data to numeric? Yes. It's all maths, right? I want to calculate the probabilities. I want to do sum and all. So I cannot do for strings. I have to convert that to numbers. For decision tree regression, I'll just ping you the link. Give me a second. Here is the link. All right, so if you like more sessions like this, go ahead and you can submit the feedback and we'll have more sessions like this on various different topics. It's 1 hour session, so obviously I have to rush as well, but I hope you got a bit of idea how it works. And yeah, have a nice day and we'll see you in the next session. Till then, take care, guys.